Hi, my dear students. I am Sunira from Department of Physics, Government College, Madapalli. In this lecture, we will discuss about AND gate. Okay. In our previous lectures, we learned about logic circuits and fundamental logic gates. Then we mentioned that there are three fundamental gates: NOT, OR, and AND gate. Okay. Then we learned about NOT gate and OR gate, how to implement in laboratory using diodes, this OR gate, using transistor, the NOT gate, etc. Now in this lecture we will discuss about this AND gate. Okay. All these are gate is used to express logics, right? Gates are the basic units of logic circuits. The one of the gate is AND gate. Okay, we already learned about three fundamental gates, right? There are three fundamental gates: NOT, OR, AND. Okay. In these gates we already learned about NOT gate and OR gate. Now we will discuss about AND gate. Okay. So AND gate is also known as all or nothing gate, because here at least this gate has two inputs and one output. Okay. There are at least two inputs. Okay. At least two inputs, or you can write it as two or more inputs. Okay, there are two or more inputs for AND gate. For AND gate. Okay, the next thing is it has only one output. Okay, only one output. Minimum there are two inputs for an AND gate and only one output. Okay, the other point in connection with the other gates, you have to remember that AND gate is known as all or nothing gate, because if its input, all inputs are high, then only AND gate give high output. Okay, so this gate is known as it has high output. Okay, high output only for all inputs are high. Inputs are high. Okay, so this gate, this AND gate has high output only for all inputs are high. Okay, then only we get high output. So this is known as all or nothing gate. Okay, this is known as all or nothing. All or nothing gate. And it is known as all or nothing gate. Okay. Now I will show you the diagram how to represent AND gate. Okay. That means the symbol of the AND gate. Symbol of the AND gate is given by, this is the notation used to represent AND gate. It has only one output pin is shown here. This side is input side. If it has only two inputs, this is the input part. Okay, this is the symbol for AND gate. These pins are two inputs, A and B. A and B equal to y equal to A and B. This dot represents logical AND operation, not multiplication. This represents logical AND operation. Y equal to A and B. Okay, this is the symbol. Now we can write its truth table. Okay, truth table. Truth table. There are two inputs A and B, and only one output. Output is represented by Y. Okay. There are three columns, two for inputs and one for output. Now, as usual, we have two square rows, right? Because only two inputs. How many inputs are there? That much rows. If n inputs are there, you have 2 raised to n rows. Okay. So here there are only two inputs. So you have 2 square, 4 rows. So 0, 0. So you can write here 0 and 0 gives you 0. Okay. Then 0 and 1. 0 and 1. 0 and 1 gives you again 0. Similarly, 1 and 0. 1 and 0 gives you 0 again. Finally, 1 and 1. 1 and 1 gives you 1. Okay. From this truth table, there is the truth table. You can see that if all the inputs are high, then only AND gate gives you high output. Otherwise, its output is always low. Okay, 1 represents high output and 0 represents low output. Okay, so these are the main points connected with the AND gate. If there are more inputs, you can draw that much pins in its input part. If there are 3 inputs, you can draw here 3 pins to represent its inputs. Now, we will check how to construct an AND gate using 2 diodes. The circuit is shown here. You can see here these are the 2 inputs A and B. Okay, A and B, 2 inputs. And the 2 diodes are connected like this. This is the negative point of the diode. This is the positive part. And there is a load resistor RL. And another power supply plus VCC. Here is also there is a power supply plus VCC. Let it be 5 volt. Okay. This is also 5 volt. Now we measure the output across this junction. Okay. This point and ground. This is the output. Okay. Now we have to check whether this circuit satisfies the truth table of AND gate. Okay, for that we will try one by one. The first case is these 2 inputs. The inputs of A and B both are 0. 0 means you have to connect this with the ground. Okay, A is connected to this ground and B is also connected to ground. That means these 2 ports are 0, 0. Okay, then what happens? If you give these 2 ports this ground, these diodes get forward biased. Right? This diode is forward biased and also this one is also forward biased. So what happens? This shorted through this line. Then if you measure output at this point, you will get 0 voltage. Nearly 0. Actually it is not exactly 0. Nearly 0. 0.7. The drop across the diode is there. But it is very low, less than 1. Okay, so you can treat it as 0 volt. That means if you give 2 inputs 0, 0, it gives you 0 output. Okay, I can write here the case 1. both A and B are connected to ground. Are connected to ground. Okay, both this A and B are connected to ground. Then what happens? The two diodes are forward biased. Okay, forward biased, and so output is 0. Output is 0. Okay, so the first condition is get here. That's you get that 0 and 0 equals 0. The second case is one of this. Let it be B. B is high. That means you have to connect this positive, this voltage to this. B is high, but A is grounded. Okay, then this A is forward biased, B is reverse biased. Okay, so A makes a closed circuit like this, and again the output voltage is 0. Okay, here A is grounded, but B is positive voltage for 1. So E conducts and Y is 0. Okay, that means 0 and 1 equal to 0. Now you can check the third case. Third case is just like our previous discussion, but this time this A is connected to this high value and B is grounded. Okay, so B is forward biased, A is reverse biased. So this circuit passes through like this. Okay, through this. So what happened? There is no output across this junction. Third case also. Third case is, this case is symmetric. Case is symmetric with case 2. So 1 and 0 equal to 0. Now our fourth case. What happened in fourth case? In that case, both these inputs are connected to high voltage. Okay, connections are like this, from here to here and here to here. Okay, so what happened? These two diodes are reverse biased because at this end they get positive voltage. So these two diodes are reverse biased. There is no conduction through this line. This voltage passes through like this, and you get a voltage drop across this 5 volt drop here. Okay, so you get output as 5 volt. In third case, A and B are positive. So diodes are reverse biased. Okay, diodes are reverse biased. That means 1 and 1 equal to 1. Okay. So from this analysis, we can conclude that our circuit behave just like AND gate. Okay, this circuit behave just like AND gate. So using two diodes and two power supply like this 5V supply, you can construct AND gate in the lab. Okay, so try to draw this circuit diagram and check how this works just like AND. Now we can try to write the truth table of an AND gate with 3 inputs. Okay, write truth table of 3 inputs AND gate. Okay, 3 inputs AND gate. So symbolically we can draw and write this as, this is the AND gate, we already learned it. This is its output pin. It's already given that there are 3 inputs. So you have to draw here 3 inputs like this, A, B and C. Okay, Y equal to A, B, C. Now this Y equal to A, B and C. Okay, now we can draw its truth table, write its truth table, right? That means this is A, B, C and Y. There are 3 inputs, so 3 columns are there for inputs and 1 for output. Now how many rows are there? Okay, there are 3 inputs, so 2 cube rows are there. Okay, 2 cube means 8 rows. Now we can write all the combinations 0, 0, 0, then 0, 0, 1, then 0, 1, 0, next 0, 1, 1, then 1, 0, 0, then 1, 0, 1, okay, then 1, 1, 0, then 1, 1, 1. Okay, these are the different input combinations. You can see that 4, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, all ones. We already learned that the AND gate is high, output is high only for all inputs are high. So this 3 input case also, you have output high only for this last case. In this case, all the 3 inputs are high. Okay, all other case you get 0, 0, 0, 0, 0, 0, 0, 0. Okay, so 1 and 0 gives you 0. 1 and 1 gives you 1. Okay, these are the truth table corresponding to 3 input AND gate. Okay, now we already seen in other case, the case of other gates. Here also there is TTL circuit. TTL means IC. So if you want to construct a complicated logic circuits, it's always better to use these ICs rather than this transistor and diodes, etc. Okay, so for AND gates, the very common IC or TTL is called IC 7408. Okay, TTL circuit, transistor logic. For AND gate, it is known as IC 7408. Okay, IC 7408. As we already learned, this IC also has 14 pins. 14th one for plus VCC and 7th pin is grounded. Now there are only 12 pins. Okay, so there are 4 AND gates with 2 inputs. Okay, 4 AND gates with 2 inputs. So we can draw here the detailed circuit. This is our IC. This is 7th pin, which is grounded. Then 6, 5, 4, 3, 2, 1. Okay. Now there are this one is 8, 9, 10, 11, 12, 13 and 14. Okay. 14th pin is plus VCs. Now there are AND gates such that 1 and 2 together form 1 AND gate like this. Then 4 and 5 together forms. Here also these are the AND gates. IC 7408. Okay. So here this 1, 2 and 3 together constitutes a 1 AND gate. 4, 5, 6 together another one. 10, 9, 8 together another one. 13, 12, 11 together the 4th gate. So there are 4 AND gates in this IC 7408. These 4 AND gates are independent ones, so we can use it each one as per our needs. And the power supply, this plus VCC and ground are common for all the gates. Okay, so if you want to design logic circuits in laboratory, you can use for AND gate these types of IC 7408. Okay, now we can try to draw timing diagram. So here the signals are like this. These are our pins, and the first pin has signal like this, and second pin has signal like this. Okay, for this gate, we draw more this about this gate. Okay, so now we can check what happens to this signal. Up to A, both signals are low, so you have here low. Then both signals are high, so you have high. Then both signals are low, so you have low again up to C. Then you have 1 and 0. 1 and 0 means 0 again, low again up to here. Then low and 1, so low again. Again low and low, so low again up to E. Then both are high, so this signal goes to high up to this much. Here again the signal goes to low like this. So the timing diagram of the AND gate looks like this. If your signals are like this, pin 1 and pin 2 are like this, you have output at pin 3 in this form. Okay. So try to understand this AND gate and its functioning, how this pin diagram is drawing, and writing the truth table including the inputs. This truth table corresponds to 3 input AND gate. Okay. So I think I can wind up now. In this lecture we learned about AND gate. AND gate is all or nothing gate. And so if all inputs are high, then only you have one high output. Okay. High means 1. Okay. Then we learned about its symbols, writing truth table, and implementing the AND gate in laboratory using diode circuits and its functioning, how it behaves like AND gate. And then we discussed TTL and IC 7408, how it works, and the pin diagram of the timing diagram of the gate 1, 2 and 3. Learn well. Thank you.